Lesson 12.1, we're going to look at something called the fundamental counting principle. The fundamental counting principle defined for you is, or to find the total number of outcomes, you multiply the number of outcomes for each event. And we're going to look at it, how it relates to independent events and then also dependent events. Independent events, the outcome of one event does not affect the other. They are independent of each other. The outcome of the first event, for example, does not affect the next one. So if we look at this first example here, it says a sandwich menu offers customers a choice of white, wheat, or rye bread. With one spread, you either choose butter, mustard, or mayo. How many different combinations are possible? I am going to make a tree diagram first, and then we will look at using the fundamental counting principle also. But the tree diagram helps us to list what's called the sample space, or all the possible outcomes. And sometimes you will be asked to do that. So, if we're going to make a tree diagram here, I'm going to label the first column bread. And we have three types of bread. We have white, we have wheat, and we have rye. So three types of bread. And then a tree diagram has branches coming off of it. So let's say with white bread, we're going to look at the spread that we can put on it. Now, there are three different types, butter, mustard, or mayo. So off of white bread, we need three branches. And so we'll put the spread over here. And we're going to have butter, mustard, and mayo. And then off of wheat, if we choose wheat bread, or if wheat bread was chosen, we will also have those same three. So butter, mustard, and mayo. And likewise, if we choose rye, we will have those same three coming off there as well. Butter, mustard, and mayo. So, if they asked you to list the sample space, which are listing all possible outcomes, you would say white with butter, white with mustard, white with mayo. They would be three of them. Wheat with butter, wheat with mustard, wheat with mayo. That would be three more of them. Rye with butter, rye with mustard, and rye with mayo. Okay, so if you look, that would be listing the sample space. I'm not going to actually do that here, but you may be asked to do that. Listing all your possible outcomes. But there would be 9 possible outcomes that I just said right there. Now, with the fundamental counting principle says this. We multiply the number of choices for each thing together. In this case, we're choosing the type of bread, and we have three types of bread. So this is the bread. And then we have the spread, 3. So we do 3 times 3, which is 9. So if they just asked you to find how many outcomes, you could just do that. If they asked you to list the sample space, you will need to make a tree diagram and then list all your possible outcomes. Okay, and then more with the fundamental counting principle. For their vacation, the Murray family is choosing a trip to the beach or to the mountains. So we have two choices of where we're going. They are going to either The transportation mode is going to be either a car, a plane, or a train. How many different ways can they select a destination followed by a means of transportation. So, destinations, either going to the beach or to the mountains. So there are two. And then we're going to multiply that times transportation, how many choices we have for transportation, and they can either go in a car, plane, or train. That's 3. So fundamental accounting principle says I multiply those two together, which would be 6. So in this case, which was a multiple choice, it would be C. If they asked you to list the sample space, you would say beach in a car, beach plane, beach train. That would be 3 of them, and then you would have to say mountains in a car, mountains plane, and mountains train. There would be 6. More than two. It's possible to have more than 2 independent events. How many codes are possible if there are just 2 digits? Okay, and when we say just 2 digits, digits are any digit 0 through 9. Any digit 0 through 9. So if we have 2 digits possible, and we can use any of the digits in those 2 places, and if it doesn't say anything about that you can't have repeats, that's what makes it independent here, and it doesn't say anything that you can't have repeated digits, and we'll get to that later. That would make it dependent, but there would be 10 digits in the first spot. I could put any of the numbers 0 through 9 there, and then I could put, if we're allowing repeats, I could put any of the digits again 0 through 9 there, and we would just multiply them. Fundamental accounting principle says multiply the number of choices of each, so there would be 100. Let's say we had 3 digits, and it doesn't say anything about you can't have repeated digits, so that would be 10 times 10 times 10, or 1,000. Last thing we'll talk about here is dependent events. Dependent events, the outcome of one event affects the next event or future events. So here's an example that deals with that. Charlita wants to take 6 different classes next year, assuming that each class is offered each period. How many different schedules could she have? So she's got to take 6 different classes in 6 different hours or periods. So she's going to take something first hour. How many choices does she have for that first hour class? Well, she could take any of this is provided that all the classes were offered all 6 hours, which realistically maybe they wouldn't be, but we're going to pretend that they are here. So I could take 6 classes there. Now, once she takes a class first hour, she's not going to take that the rest of the day. So then that means there's 5 classes left for second hour. Once those 2 get filled, there's 4 classes left for third hour, 3, and so on down. The fundamental accounting principle says I multiply all those together. So it's 6 times 5 times 4 times 3 times 2 times 1, and that would equal 720 possible schedules that she could have. And that is the lesson. So with dependent, you're going to decrease by 1 each time. And that's like the ones when we looked at the codes. If you have 3-digit numbers and you can't allow repeats, then you would decrease 1 each time, but you still multiply together the number for each, and that's what the fundamental accounting principle says.